Page 39, problem number 21 reads, determine the open intervals over which the function is increasing, decreasing, or constant. And we're given a function, we're given a graph of the function. Let's just look at this graph. The graph goes upward, then downward, then upward. So we can say the graph starts out increasing. So let me just write that down. Then it is decreasing, and it finishes by increasing. So what I have to do is define these intervals. When is it increasing? When is it decreasing? And when is it increasing again? Basically, I define them by looking at the x values. It's like saying if I plug in these certain x values, the function itself, the y values, are increasing. If I plug in some certain x values later, the function will be decreasing. And if I plug in some certain x values later, the function will be increasing once again. So if I look at this function, it's increasing forever until I get right here, until I get to this x value right here. So any x values I plug in, all the way from negative infinity all the way to this x value, my function is increasing. So I can write that this way. I can say my function is increasing along this interval of x values from negative infinity until 0. So along that entire stretch of the graph, my function is increasing. Now between this value and this value, my function is decreasing. So for any x values between 0 and 2, the graph of the function goes down. Now, last but not least, from that point onward, forever, it appears as if the graph of the function is increasing. So from 2 forever onward, up to infinity, the graph of the function is increasing. So it's increasing, then decreasing, then increasing along these intervals of x values.